Okay, here we go. We'll turn the music off. Alright. So this is the first video I've filmed for this project. This is the final revision of my Rapidstrike motor control circuitry. Maybe if I turn this light off, you can see the LEDs better. No, it's about the same. Alright. So what I have my two main buttons here. I have my flywheel button and my, the other one that I can remember because I can speak English. Shit, what's it called? Pusher. Yeah, that one. The pusher motor button. Yeah, sorry about that, guys. I'm sure that was entertaining to listen to for 10 seconds. Alright, so, yeah, main trigger buttons, basically. Oh, one's hooked up, as you can hear. Then I have over here, let me get my finger in the shot. There we go. I'm only using two of these 4 switches, but these switches increment the counter and also show off how dirty my fingernail is. So it increments the counter, which, if you look over here on this display, pulses. So I have 8 different levels because I'm just using a shift register. And you'll notice how the last 3 light up. I'm going to rewire it so the first 3 light up, so it'll look like that on the first press, and then up through the stack. So that goes to an array of 8 values. 8 values to step through the LED display, and 8 values to step through the ESC speed on this brushless motor, which is right there. And here's the ESC. I have the values for the Hobby King Afro ESCs programmed in right now because that's what I'm going to use in the gun. This is just something I got off of Amazon that I could use for prototyping. I don't think it's calibrated properly. I could probably recalibrate it. I actually did initial calibration with some serial stuff on the Arduino. However, I think with this circuit and the right ESCs, you don't need to do that. I could be mistaken, but once this is all built, if I need to calibrate it, it's a simple matter of just hooking this guy up, setting it to calibrate, and there you go. So, as you can see, this guy steps through his values. The other one steps as well. That's the other button, so it's 2 parallel circuits. I am running these shift registers in parallel. I'm actually using 6 pins, so I'm using pins to drive each of them. I tried running them in series. I just can't figure out how to control them independently and have them both reset like that. There's probably a way. I just don't have the knowledge because this is the second project I've done with this Arduino. The first project was just getting the buttons up and running. So, alright, so I'll see if I can, this is going to take 2 hands. I'm going to see if I can run the motor and step through the speeds. I'm going to see if I can prop the camera up, which I don't think I can actually do. So maybe I can just, oh, I think I can get the buttons with my left hand and film it. Alright, so you're going to hear the motor run because I'm going to push the button and you can watch me toggle through values. So right now it's off. And you'll notice for the rest of these values, it doesn't actually increase. That could be a limitation of the power supply, which is just a little 15 volt 3 amp guy. Ideally you need a battery so it can pull a significant chunk of current out of there. So it could be current. It just could be the microsecond PWM pulses going to the ESC. I will continue working on that, but I'm not really going to try to tackle that until I'm back in the States and I have the actual ESCs and motors and the actual batteries I plan on using, which it occurs to me I need to buy. So, yeah. So this is the first video I've made for the Brushless Rapidstrike project. I'm calling it MOAR, Mother of All Rapidstrikes, because it's going to be pretty insane. And really, it was an excuse for me to get into Arduinos. In the back of this breadboard, you see here 2 other displays. These are 3914s, 3714s. See if I can get it. Well, they're LED drivers, so you can actually drive a 10-segment LED with these and turn it into like a VU meter, and just pretty much just straight up. If you search these parts on eBay, you'll see this chip bundled with this. I bought them as a possible example, as a possible solution. However, I wanted discrete control of the LEDs, and the shift registers offer that. If I really wanted full 10 digits, 10-step control, what I could do is add a third shift register and just spread these values across and just independently address those. It would take 3 more pins and a lot more wires, and honestly I think 8 steps is enough. It takes a little bit of time to cycle all the way through the speed ranges, and I think that 10 would just be even worse. I may actually end up turning it down to like 5 speed ranges for the flywheels, and then, you know, I'll probably keep all 8 pusher speeds, because once I get those dialed in, I'm hoping it'll be a dart per second from 10 darts to maybe even up to 18 if the flywheels go fast enough, or the pusher goes fast enough. Other than that, you can see I have a whole bunch of resistors tying all these guys to ground and not overloading the switch pins on the shift registers. Have a nice little 1 microfarad Mylar bias cap just to kind of eat up some of the all voltage spikes of all this stuff switching around. And back here is just a little 7805 that is powering all my rails. The 7805 is going to go into the gun. The ESCs I got are opto. This is also opto, so it doesn't have a battery elimination circuit in it because I didn't need it. I don't want the heat or the waste. Actually, and if you get an ESC that has a battery elimination circuit, you just make sure to only connect, see if I can get this in the shot, only connect basically the data pin and the ground pin. That red wire in the middle that is not connected would be where the voltage would return into the Arduino circuit. You could theoretically power it that way if you wanted to, but there's no reason to. I prefer to keep everything isolated, keep my rails as clean as possible, because once these motors start kicking around and changing the speed, there's going to be a whole lot of noise in the circuit, and I'd rather keep as much of that out of my electronics as I can. Alright, so that's that. It's very messy. Here's a shot out the window of what Amsterdam looks like when you're in a hotel on a Monday evening. Here's my very messy, tiny hotel room. Yeah, tiny. That wall is about 8.5 feet away. There's a bed with all my Arduino stuff on it. Anyway, alright, so I'll do a couple more of these as we keep going, but here is the circuitry. Yeah, I fried my brain a couple times in a row building this thing, figuring out what the hell it was doing, and then of course in the end it only took about 45 minutes. But that's how you do. Alright, till next time.